Welcome to the quiet space of our community where sleepy stories live. Maybe it's been a long day, or perhaps you just love falling asleep with thoughts about distant space instead of counting elephants. Today we'll gently travel from our small planet to the Milky Way and beyond, into the vast structure of the universe, where galaxies are connected in threads, walls, and invisible webs of dark matter. You don't need to do anything right now, just settle in comfortably, let your breathing slow down, let your thoughts soften, and your body become light, as if gravity has loosened its grip. We'll go slowly, gently, just one sleepy fact at a time, leaving everything else beyond the boundaries of this night. And before we begin, if these quiet journeys help you relax and gently end your day, please tap the like button and subscribe to the channel. It helps others find their way here too, as if one by one we're lighting nighttime beacons of calm. And now, settle in comfortably and let's begin. We live on a small sphere with a diameter just over 12,000 kilometers. If you imagine Earth as a grain of sand, then even our solar system becomes a small neighborhood in a gigantic cosmic city. This doesn't diminish our significance, but rather adds a sense of freedom. We're part of something very large and peaceful. Now, let's look at exactly how these immense distances are measured. An astronomical unit is the average distance from Earth to the Sun. It equals approximately 150 million kilometers. But it's more convenient for us to think of it as one step outside the house on the scale of the solar system. All the planets move as if on rings around a lantern, and these rings are conveniently measured in exactly such steps. And then comes a unit that's suitable not for planets, but for interstellar distances. A light year is the distance that light travels in 1 year through the void. Light is very fast, but even it needs years to pass from one star to another. You can imagine this as a thin thread that someone pulls through the darkness, very slowly unwinding a ball of yarn. And we can already look at what's at the ends of these threads, our nearest stars. The closest star to us after the Sun is Proxima Centauri, about 4 and change light years away. And the nearest large galaxy is Andromeda, and its light travels to us for over 2.5 million years. We see it as it was when humans didn't even exist on Earth yet. And this is just the beginning of the journey outward. Further on, the structure becomes even more amazing. Take a slow breath in and an equally slow breath out. Imagine that with each exhale you're floating away from Earth a little further, but at the same time you feel safe, as if in a soft boat. Galaxies are rarely completely alone by themselves. They gather in clusters and clusters into superclusters, which stretch for hundreds of millions of light years. If you look at these scales, the universe resembles a three-dimensional web where galaxies are beads on thin threads. And we live in one of these beads, in a quiet corner of this cosmic network. The largest structures we notice are superclusters of galaxies. They don't hold together as tightly as individual clusters, but they form denser sections in this cosmic web. Our Milky Way is part of the local supercluster, where we're located not in the very center, but rather on the quiet periphery, away from overly turbulent zones. It's like living far from the center of a metropolis, less noise, more chances for a peaceful life. Between the threads of galaxies lie huge, almost empty regions, voids, cosmic emptinesses. In them there are 10 times fewer galaxies than the universe average. Imagine soap bubble foam. Matter collects along the walls, and inside are large transparent cavities. Only instead of soap foam, there are billions of galaxies here, and instead of bubbles, space spanning hundreds of millions of light years. Sometimes threads and clusters form entire walls, flat structures of enormous length. Some of them stretch for hundreds of millions or even billions of light years. There's the Hercules Corona Borealis Great Wall, which occupies about 1/10 of the diameter of the observable universe. And you and I belong to the closer wall, where the Virgo cluster and our local supercluster of galaxies lie. You can imagine that you're looking at these walls not from the inside, but from afar, like at a pattern on a carpet. At such a distance, everything looks smooth and flowing, without threat, just a beautiful structure. If you take a cube of space measuring several hundred million light years on a side, it will contain approximately the same number of galaxies, clusters, and voids wherever we place this cube. At such scales, the universe can be considered homogeneous, though at smaller scales, it's very patchy and uneven. This gives a sense of stability. In the big picture, the view is approximately the same everywhere. And it's precisely against this background of uniformity that special structures are clearly visible: walls, threads, and our galaxies. Some walls are so large that they exceed the scales predicted by standard cosmological models. They seem to tell us the theory is good, but we need to tweak the details a bit more. One such structure is tens of times larger than the sizes where, according to theory, the universe should already be completely averaged out. This isn't cause for fear, but rather an invitation. Space still holds mysteries for us. The modern picture says, in the early universe, matter was very uniform, with barely noticeable ripples in density. This ripple was reflected in the brightness of the cosmic microwave background radiation, a quiet glow that fills space. Over time, gravity gradually pulled together the denser areas, and they grew, forming first small clumps, then galaxies, and then clusters. Like from barely noticeable waves on water, a large, peaceful pattern is gradually born. For this structure to grow so quickly over 13 to 14 billion years, ordinary matter alone isn't enough. That's why cosmologists introduce dark matter, invisible substance that doesn't shine and doesn't reflect light, but has gravity. You can imagine it as an invisible framework to which ordinary gas sticks, and then stars are born in it. Without this invisible foundation, the universe would remain almost empty, without galaxies, and without us. Take another slow breath in. You can imagine that all dark matter is simply a soft pillow on which stars are scattered. They lie peacefully. Nothing is rushing anywhere. Everything unfolds on incredibly long time scales. Dark matter is judged not by light, but by how it curves trajectories. Galaxies rotate as if they have more mass than can be seen from the stars and gas. And gravitational lensing, when massive clusters curve the path of light from distant galaxies, shows the mass there is as if several times greater. This is like a transparent glass object. You don't see it directly, but you understand it's there by how it distorts the image behind it. Dark matter helps galaxies hold together. Without it, stars and spirals would have long ago flown apart in different directions. It's like invisible glue that gently holds everything together, not compressing, but not allowing it to scatter. And thanks to this, our Milky Way remains a peaceful home for billions of stars, and for you and me. We live approximately 26,000 light-years from the galactic center. This is a distant suburban district of the spiral disk in one of the arms. There's less harsh radiation here, fewer chaotic collisions and explosions than closer to the center. You could say we live in a quiet outskirt of a large stellar city, and it's precisely because of this that life has a chance to be stable. Try to feel what it's like to live in a quiet district of a huge galaxy, like your house stands on a quiet street, far from the highway where it's always noisy. In the center of our galaxy, there's a supermassive black hole, Sagittarius, a star. It's millions of times heavier than our sun, but it's located so far away that it poses no threat to us. Around it orbit stars like swift little lights around a dark stage. This place is more like a distant city center that we don't even commute to, we just know it's there. Stars are born in cold clouds of gas and dust that slowly compress under the action of gravity. When it gets hot enough inside, thermonuclear fire ignites. A star lives for millions or billions of years and then peacefully completes its journey, sometimes with a bright flash, sometimes simply dimming, becoming a white dwarf or neutron star. These cycles are so long that all of humanity lives its journey like a moment against the backdrop of one stellar biography. The elements in our bodies, carbon, oxygen, iron, were formed in stars. Some in the cores of ordinary luminaries, some in the explosions of massive stars that scattered heavy elements across space. Every cell in you is literally assembled from the dust of old stars that have long since gone out. This shouldn't be frightening. Rather, it's calming. We're part of a natural, effortless circulation of matter in the universe. Take another calm breath in. You can quietly tell yourself, I'm made of the same matter as the stars. Let this thought settle somewhere deep and warm you. In our perception, space seems black, but this is rather a limitation of our vision. If you could see all wavelengths, from gamma rays to radio waves, the sky would be filled with light. Stars, nebulae, dust, hot gas, all of this glows, reflects, or scatters radiation. Darkness is rather a background against which all these soft reflections become more noticeable. In the spiral arms where active star birth is still going on, live young blue and bluish stars. Closer to the center, there are more old yellow and red stars that have long been burning their fuel more slowly and peacefully. It's like different districts of one city, somewhere young, noisy neighborhoods, somewhere old, quiet buildings. You and I live somewhere in between, in a zone of soft balance. There are nebulae that glow because they still have hot matter after the death of a star. There are dark clouds where gas is only preparing to compress to someday ignite new light. Some of them we see only in the infrared range. They're invisible to the eyes, but telescopes catch their warm smoldering. It's like looking at embers in a stone. Some have already gone out, some are still quietly glowing. If you want, You can close your eyes for a moment and imagine that the whole galaxy is a large, slow fireplace. Somewhere something is just being kindled, somewhere it's already turning to ash, but on the whole, the picture is calm and predictable. The universe is expanding. Galaxies, on average, are moving away from each other. This doesn't mean we're flying somewhere in the center of an explosion. Rather, space itself is stretching, increasing distances. There's a boundary beyond which we see nothing, because light simply hasn't had enough time to reach us. This is our observational horizon, like the horizon line on Earth, only cosmic. The oldest signal we see is the cosmic microwave background radiation. It appeared when the universe cooled down enough that neutral hydrogen formed from protons and electrons, and light could propagate freely. This distant surface is also called the surface of last scattering. Everything that was deeper, even earlier, we don't see directly, but we can judge it by its influence on what we observe. Modern measurements show that the universe at large scales is very close to flat. This means that parallel lines in it practically don't converge or diverge. If a radius of curvature exists at all, it's at least 10 times larger than the size of the observable part. For us, it's like for an ant on a huge ball. On its small section, it sees an almost flat plane. Think how calming it is to realize. At all scales we can observe, space behaves smoothly and predictably. No sharp edges, no cliffs, just slow, smooth geometry. There's a hypothesis that the universe might be multiply connected, like a three-dimensional donut. In such a space, moving in one direction for a very long time, you could theoretically return to the same point. Some features of the relic radiation, the absence of large fluctuations, can be explained precisely by such topology. Then the universe has a finite volume, but still feels boundless, because the boundary is nowhere felt as a wall. Observations show galaxies are moving away from each other with acceleration. To explain this, they introduce dark energy, a special form of energy of space that pushes everything outward, like someone slowly increasing the size of the room we're in, but the walls are so far away that we simply feel more free space. And all this happens on billion-year timescales, not affecting our daily life at all. The European Space Telescope Euclid was launched in 2023 to the Lagrange point L2, far from Earth's noise. It looks in the optical and infrared ranges, having a huge camera with hundreds of millions of pixels. Its goal is to create a three-dimensional map of billions of galaxies so that by their shape and light distortion, we can sense where exactly dark matter is hiding. It's like doing an MRI of the entire universe, but in a very calm, slow mode. Imagine how the telescope quietly floats in the cold darkness near L2, far from Earth. All around is silence, only slow rotations and rare corrections, and nearby, no one. The first large images from Euclid already showed millions of galaxies in one frame. Some of them we've never seen before. Others now appear with new clarity. In such pictures, you can see both clusters and thin threads and faint clouds of dust in our Milky Way that glow in the infrared range. This is only a tiny fragment of the future map, but it already resembles huge stellar lace. Dark matter and dark energy together make up the larger part of the universe's energy balance. You can imagine that everything we see, Stars, gas, planets is only a thin film on the surface of something bigger and invisible. But this invisible part behaves stably and calmly. It doesn't attack us, but simply sets the overall shape of the universe's evolution. Telescopes like Euclid don't make space scary. They simply allow us to see another layer of order. James Webb looked even deeper into the past than Hubble. It saw very distant galaxies whose light has been traveling to us almost from the beginning of cosmic history. Some of them turned out to be more massive and more ordered than theories expected. There you can already see structures, black holes, and heavy elements. This doesn't destroy the picture, but forces us to clarify the details of the scenario by which the first galaxies assembled. Everything that James Webb discovers happened over 1 billion years ago. What we learn today doesn't change our present calm at all. It only adds depth and beauty to the picture of the past. Earlier, it was thought that the first galaxies were predominantly chaotic clumps without distinct shape. New images showed, even at large redshifts, quite a few galaxies have spiral structures similar to our Milky Way. It turned out that regularity can appear earlier, and chaos and mergers don't always destroy beautifully ordered disks. This is another calm hint. Order in the universe arises not only at the end, but quite early. Simulations once predicted that massive galaxies in the early universe should be rare. James Webb saw that there are more of them than expected, and they appear already in the first billions of years. This isn't a threat, but a sign that our models need a new touch. The universe turned out to be a bit more productive at creating large galaxies than we thought. To find out how far certain stars and galaxies are, astronomers use a whole ladder of methods. Nearby stars are measured by parallax, a small shift against the background of distant luminaries as Earth moves around the Sun. Then come Cepheids, stars whose brightness changes with a period related to their true luminosity, and then the red shift of galaxies. Thus, they build a bridge from neighboring stars to the edges of the visible universe. You can imagine these methods as invisible threads stretching from our sky to distant objects. Each thread is a way to gently reach out to something very distant without disturbing it from being itself. The age of the universe is about 13.8 billion years. But because space is expanding, the true radius of the observable part is larger, approximately 40-something billion light years. What we see at the edge is light that has been traveling to us for a very long time, while all the space between us and it was stretching. And yet this is only a piece of a potentially larger, perhaps even infinite universe. If the universe is truly infinite and approximately homogeneous, then in every sufficiently large region, there will be similar conditions. Wherever you end up, billions upon billions of light years away, there too will be galaxies, stars, planets, and their own local particle horizon. This is like an infinite field where every observer sees their own bubble universe, but the structure is similar everywhere. Such a picture isn't frightening, but rather expands the sense of home much further than our galaxy. In physics, there's a quantity called entropy that describes the measure of disorder in a system. In closed systems, entropy on average grows. Ordered states transition to more chaotic ones. Gas from a burst balloon won't gather back all into that same volume. An ice cube in warm water will sooner or later melt. However, in short intervals and in individual regions, local islands of order can arise, such as galaxies, stars, and you and me. Think how strange and beautiful it is, against the background of a general tendency toward dispersion. From time to time, islands of structure arise. We live precisely in such an island, and this isn't cause for anxiety, but rather for quiet wonder. For some systems, theory predicts over a very long time they can return to a state close to the initial one. This is called Poincare recurrence. On the scale of the universe, this sounds like the possibility of cycles, expansion, compression, and expansion again. Such models aren't proven, but they show that even in chaotic processes, there can be a deeper rhythm. Some ideas suggest our universe could have arisen as a rare fluctuation in a larger, almost equilibrium super-environment, like a tiny bubble universe that spontaneously surfaced from chaos and began to expand. In such an approach, the beginning isn't a single moment, but rather a statistical event. This is already the boundary between physics and philosophy, but even here you can feel order and probabilistic rhythm, not sharp chaos. Some alternatives to the classic Big Bang describe a universe without a point, where everything is gathered in zero volume. Instead, smooth transitions, soft phases of compression and expansion. Space doesn't explode, but rather awakens, slowly stretches and changes. Such a picture sounds calm. It's not once and for all, but a long process that's in no hurry. If you feel your head is a bit tired from theories, allow yourself to just listen to the voice and words as a soft background. You don't have to remember everything. Space isn't going anywhere. In some theories, our universe is a three-dimensional membrane in a space of more dimensions. Such membranes can approach each other, touch, and then entire cosmic cycles arise. In each cycle, its own universe can be born with its own details, but the general laws remain similar. This is almost like a fairy tale for the mind, but in it, as in children's stories, there's a lot of calming repetition. Roger Penrose proposed the idea of conformal cycles. Our universe may be one of an infinite sequence of eons. Each eon begins with a smooth, hot state and expands for a very long time under the action of dark energy. When only radiation remains, scale ceases to matter, and such a phase becomes like a new beginning for the next eon. Thus, the end of one world smoothly transitions into the start of another without a sharp break. There's an approach in which space and time aren't the foundation, but derivatives of a deeper reality connected with information. Like temperature arises from the motion of molecules, so time may simply be a convenient description of a sequence of events. In this picture, it's not very correct to ask when exactly everything began. What's more important is how the states of the system are connected to each other. This is complex, but there's also a special form of calm in this. There's no rigid starting point, but a smooth flow of states. Take a slow breath in and a long, calm breath out. Everything we're talking about concerns billions of years and colossal scales. Your night today is a very small, safe fragment of this large canvas. We know perhaps a few % of what's really happening in the universe. This is more like we're standing in a small room of a huge castle and only occasionally peering through the cracks of doors into neighboring halls. Somewhere there are towers, bridges, large halls, but we haven't reached there yet. And in this there's not hopelessness, but intrigue. There are many quiet discoveries ahead. In billions of years, our galaxy and Andromeda will approach and begin to intertwine. The distances between stars are so great that most of them won't even collide. They'll simply change their orbits. This won't be a catastrophe, but a slow dance of two stellar cities that will merge into one larger one. And this will happen so far in the future that humanity will most likely have long found other ways of existence, if it still exists at all. Our position in the galaxy is a great gift. We're far enough from the center where there's too much harsh radiation and chaotic processes. Here, in the sun's orbit, space is much softer, fewer impacts, more stability. You could say we were born in a quiet yard of the large universe, where you can peacefully develop life and thoughts. Now we've already gone through the main facts and pictures. Further on there won't be new theories, only smooth reminders and images that help fall asleep more peacefully. Your heart beats on a small planet that circles around an ordinary star. This star is only one of hundreds of billions in the Milky Way. And you are one consciousness among billions of others who also look at the sky and ask questions. All of this isn't chance, but part of a large, slow story. The atoms in your body were once in the core of a star that has long since gone out. They went through explosions, gas clouds, gravitational dances, and calm periods. Now these atoms have temporarily gathered into you so that you can breathe, think, feel, and someday, very, very far in the future, they'll continue on their way. The processes we talked about last billions of years. Galaxies dance more slowly than we can imagine. Walls and threads of galaxies change even more slowly than the galaxies inside them. Against this background, your day-to-day is like a moment that you can simply release from your hands and give over to rest. When you breathe in and out, you're repeating in miniature the cosmic rhythm, compression and expansion. The universe was once denser, now it's larger and colder. Your lungs move thousands of times per night, and space makes such a breath over billions of years. And yet this rhythm is one and the same, calm, repetitive, predictable. Despite all the deep theories, right now you're lying in a familiar room. Your bed is a small island on large scales, but it's precisely here that you're warm and calm. The walls of the room hold space in the same way gravity holds stars in a galaxy. You can allow yourself to let go of control and simply trust this simple human coziness. When we look at the scale of the universe, our daily worries become smaller, but don't disappear. They simply stop seeming endless and insurmountable. Like we're pulling back the camera and seeing, yes, there are difficulties here, but all around is a huge field of calm. There's relief in this. Not everything rests only on us. Astronomers have only begun a true acquaintance with the large structure of the universe. New generation telescopes are already questioning old theories and offering new clues. This process won't end tomorrow or in 100 years. It will stretch across generations. And this too is calming. We're not obligated to understand everything right now. While you sleep, stars continue to shine, galaxies to rotate, dark matter to hold their orbits. None of this requires your participation to continue. Your main task this night is to rest. The universe will cope with itself just fine. Although we're not the center of space, each consciousness feels itself in the center of its own world. This is normal and natural. All feelings, thoughts, memories revolve around you. Like a small galaxy inside a large one, you have the right to your own space, your own pace, your own silence. Now this center can finally calm down. On a clear night on a dark sky, you can see the band of the Milky Way. It looks like spilled milky cloud, but in reality there are billions of stars there. You can imagine that this band is a large blanket under which the planet sleeps, and together with it, you. Space isn't only distant and cold, it's also very quiet and soft in appearance. Among all these thoughts about galaxies, walls, and dark matter, there's one simple idea. You have the right to simply be, without explaining to yourself and the world why and what for, like a star that simply shines, without composing reports about its luminosity. Tonight, that's enough. Imagine that all the words about the universe slowly dissolve like smoke in the air. Only the feeling of a large, calm space and a small, warm body inside it remains. Nothing is hurrying. Nothing demands immediate decisions. There's only night, breath, and soft darkness. All these galaxies, structures, theories, this is an attempt to describe one and the same thing, the world in which we live. And it, for all its complexity, allows life to appear, thoughts, care, and warmth. This means that at its foundation there's something very soft toward us. You can trust this feeling. This night won't last billions of years, but for you it can become a small eternity of rest. When you fall asleep, time will lose its power a bit. You'll wake up, and the universe will still be here, calm and familiar. And for now, you can just gradually let go of thoughts. Take now one deeper breath in and a slow, slow breath out. If your eyelids are getting heavy, that's normal. You can allow yourself to fall into sleep as quietly as a galaxy slowly floats through darkness. Thank you for being with me today on this quiet journey through galaxies and stardust. Perhaps you listened to the end, or maybe you fell asleep somewhere in the middle of this cosmic story. And that, honestly speaking, is the best compliment for such a night. Remember, you're part of the Milky Way. You're made of the same matter as the stars that shine in the night sky. All around is a huge, slow, calm universe, and in it, there's already a place for you, your thoughts, and your rest. May this night be soft. May dreams be bright like nebulae and quiet like distant stars. Give yourself the right to simply sleep, simply breathe, simply be. Thank you for trusting me with your evenings. Sleep peacefully, good night, and sweet dreams.